Hi everyone, this is Mrs. GA, and today we are going to learn about angle, side angle, triangle congruence. So previously we talked about CPCTC, which is corresponding parts of congruent triangles are congruent. So with CPCTC, you have to show that all of the corresponding parts, meaning sides and angles, are congruent to prove the triangles are congruent. So we're going to start learning more specific ways that we can show that two triangles are congruent with a little less information. So the first way we can prove that two triangles are congruent is with what's called angle, side, angle congruence. So if you have two triangles that have two angles and the included sides that are congruent to each other. So if you look at this picture, we have angle A is congruent to angle D. Included side means the side in between the angles. The side in between. It's included between. So if you look here, AB is congruent to DE, and you can see this side is between our two angles, and then we know that angle B is congruent to angle E. So if you know that an angle, side, angle, and an angle, side, angle are congruent to each other, then that's enough to show that the two triangles are congruent to each other. So with the information we're given, we can conclude that triangle ABC is congruent to triangle DEF. And please note that the order that you state your congruence matters. Angle A corresponds with D, so they need to go first. B corresponds with E, and then C corresponds with F. So again, this is just one more specific way that you can prove that two triangles are congruent if you have angle, side, angle congruence. So let's see if we can use this angle, side, angle congruence to determine if these two triangles are congruent. So here's what we know so far. We know that angle J is congruent to angle M. So this would be like the first step of ASA. I'm going to put an A right here. Well, and then I'm looking and I see, okay, I have a side right next to it. And then I see I have a side right here as well. So I can say, okay, I see that JL, segment JL, is congruent to segment MP. So that'd be the side of angle, side, angle. Now the last thing that we would have to prove is that the last angle is congruent. So we're working with this area and this area. So you can see here that we have to show that angle L is congruent to angle P. So in order for us to do this, we're going to have to figure out what angle P is. So we can use the fact that we know that triangles add up to 180 degrees. So we would say 180 equals 26 plus 34 plus angle P. So we get 180 equals 60 plus angle P. That means that angle P is equal to 120 degrees. So I'm looking, and for my last step, I would have to show that angle L is congruent to angle P. However, we see that angle L is not congruent to angle P. So we're not quite able to finish the angle, side, angle. So we can conclude that the two triangles are not congruent. So our answer would be that triangle JLK is not congruent to triangle MPN. Again, we found that one angle is congruent, we found the included side is congruent, but that last angle was not congruent. Okay, let's look at this next example. So here we have one larger triangle, but within it we also have two smaller triangles. So let's see if we can show that these two triangles are congruent. So one thing I see right away is that it tells us that angle B is congruent to angle C. So this would be one of the angles of angle, side, angle. And then I'm going to look at the next side. The side is adjacent to it, so I can see, oh look, in the picture I am told that segment BD is congruent to segment CD, and that would be the side part of angle, side, angle. and let's see if this last angle, if these corresponding angles are congruent. So since this is a straight line, that means these two angles are a linear pair. If this is 90 degrees, this other angle must also be 90 degrees. So I'm going to draw that in like this, which means that angle BDA is congruent to angle CDA. They're both equal to 90. And notice you can't call either of these just angle D because it's not clear which one. So you have to use three letters to name it. And this would be the last side. So by angle side angle congruence, we can state that the two triangles are congruent. So let's say I call the first triangle BAD. I need to match the corresponding parts. So B corresponds with C, A corresponds with itself, and D corresponds with itself. So again, by angle side angle congruence, we know that the two triangles are congruent, but we have to list out the parts that are congruent to be thorough. Okay, let's look here at example C. So here we are given that AB is parallel to CD. And we are also told that angle ACB, which is right here, is congruent to CAD. And let's see what else we can conclude before we try to decide if the two triangles are congruent. Since we have two parallel lines cut by a transversal, I can conclude that this angle is congruent to this angle because these are alternate interior angles. So let's start listing what we know again and see if it works for angle side angle. The first thing that we were told is that angle ACB is congruent to angle CAD. So that'd be the angle of our angle side angle. So look at this top triangle here. I have two angles. This would be my included side. So you might notice something interesting here. AC, this segment, is part of both triangles. So we can actually make this statement. AC is congruent to itself. And because it is part of both triangles, we can make this statement. So that's the side of angle side angle. So we've shown this angle is congruent, the sides are congruent, and then we can make this last statement again, that angle BAC is congruent to angle DCA. And again, we knew that because they are alternate interior angles, and that would be our last step of angle side angle. So because of angle side angle congruence, we can state that the two are congruent. So let's say I named the first triangle ACD. Let's match up the corresponding parts. So A corresponds with C in the other triangle. C in this triangle corresponds with A in this triangle. And then D corresponds with B. So it's really important that you match up, you mark up your picture with the appropriate symbol, so it's easier to determine the corresponding parts. Okay, let's look down here at example 2. Here they say for what values of the variables, so x and y, make the two triangles congruent to each other. So again, they want triangle QPR to be congruent to triangle SPR. So if we were using angle side angle congruence, we would want to show that this angle is congruent to this angle, and we would want to show that this side is congruent to itself, and then we would want to show that this angle is congruent to this angle because those are the corresponding parts of your triangles. So again, let's first show that this angle is congruent to this angle. The only way that that's possible is if we set 2x plus 7 equal to x plus 22. And here we can solve, so I'm going to subtract x from each side, and then I'm going to subtract 7 from each side, so x equals 15. So if x is equal to 15, then these two angles are congruent to one another, and that would be the first step of angle side angle. Well, we already know that a side is congruent to itself, so PR is congruent to PR. So that's the middle part of angle side angle. And then last, we need to make sure that these two angles are congruent. So we need to make sure that 8y minus 4 is equal to 4y plus 28. So I'm going to subtract 4y from each side and add 4 to both sides. So that means y must be 8. So if y is 8, then these two angles are congruent, and that would complete angle side angle congruence. Okay, the last thing we're going to try together is a proof. So here we have our formal proof setup, and we're going to try to fill in the blanks, but let's start by looking at our given information and what we're trying to prove. So first we are given that angle A is congruent to angle C. So I can mark that up here. And then we are also told that E is the midpoint of line AC. So if you look down below, the first thing they list is angle A is congruent to angle C, and of course that's a given. So we're usually going to start by listing all of our givens. So you can see their next reason is given, so that means our second statement should be the other piece of given information. That E is the midpoint of AC. So now that we've listed both of our givens, we can kind of think about, well, how can we use what we were given? So I know that if I am told a midpoint cuts a segment in half. And if a segment is cut in half, that means that the two segments it creates are always going to be equal. So we can make the statement that segment AE is congruent to segment EC, and that is because we can say the definition of a midpoint. That's what midpoints do. They create two congruent segments. So if you look here kind of at the bigger picture, since we're trying to prove the two triangles are congruent, we were trying to use angle, side, angle. They've already shown one corresponding pair of angles are congruent. They showed that the included sides are congruent. So now we have to show that these last angles are also congruent. So here they say angle AEB is congruent to CED. But we can't just say they're congruent. We need a reason. Well, if you look at the picture, we know that they're congruent because they're vertical angles. Vertical angles are always congruent because of the vertical angle theorem. So that's the last step of angle side angle. In our proof, we've shown that the first angles are congruent, the sides are the included sides are congruent, and the last angle is congruent. So that's enough for us to prove that these two triangles are congruent. So remember, our last step in a proof should always be that prove statement if we did it correctly. So triangle AEB is congruent to triangle CED. And that is by angle side angle congruence theorem, which we showed right here. All right, that is all for today's video. Thank you so much for watching.